Hello everybody. As I said in this session, we'll discuss insertion sort, bubble sort and selection sort. In the previous video, I have just discussed insertion sort. Now that we have understood insertion sort, it is very easy to understand bubble sort. So what exactly is bubble sort? Bubble sort repeatedly compares adjacent items and larger item bubbles to the left. This is exactly what we do. We will understand this statement by the end of the program. We will try to run the code and see what is the output. This is the code for the program. Actually, the output, desired output will be the same as insertion sort, because what we are doing is sorting elements in an array. But let's just try to run the code for bubble sort and see. We have given an input of 100, 50 and 10. So after sorting, the output should be 10, 50 and 100. As we can see here, the output is 10, 50 and 100. So now we will understand how we are actually getting this output by using the code of bubble sort. We will try to write the code for bubble sort and understand the program of bubble sort. I am deleting this part of the code. So this is the common part, even we have written in the insertion sort. So initially we are taking an input array, we are defining an input array and we are giving the values as 100, 50 and 10. Then what we are doing is we are storing the output in a sorted output array. Sorted output array, and we are calling the method bubble sort on an input array. Then we are printing the values of the array. We are printing the values of the sorted output array. Now we will write the method, the declaration definition of the method bubble sort. Bubble sort, insertion sort and selection sort are all similar actually. There are only minor differences in the way the code is written. But the way the sorting technique is executed is different. Here also we have two for loops. For int I equal to 0, I less than entered array dot length I plus plus for int j equal to 0, j less than entered array dot length minus I minus 1. We will discuss in a little while why we have written array entered array dot length minus I minus 1. And the values that we compare are, previously we compared key with a of j, that is key we compared with entered array of j. Here in place of key we are not, there key was nothing but entered array of I. So in place of key now we give the value as entered array of j, because we are comparing the adjacent elements, entered array of j and entered array of j plus 1. If entered array of j is greater than j plus 1, we do a swap. And what values we do want to swap? Swap j, j plus 1 and entered array. after the for loop, here we can see missing return statement. So after the for loop, we will return entered array. And we have to write the code for swap function. As I have discussed before, the swap function is similar. It is a standard function. I will just try to copy the code to save some time. But I will explain the swap function, or else you can view the previous video and understand how the swap function is written. In the insertion sort video, that is the first video in this session, I have explained how the swap function returns the value, how the swap function operates. You can understand it from there, by viewing the video. So now I'm trying to run the program just to see that if there are any errors or if the program is running perfectly fine. So the program is running fine. The output is 10, 50 and 100. Now let's try to understand how the program works. Then we will get a clear idea how each and every statement have been written in order to get this output. Before doing that, we will go to the PPT and understand the flow of execution of the BubbleSort. So as I said, BubbleSort repeatedly compares adjacent items and larger item bubbles to the right. That means we are comparing initially 100 with 50, and because 100 is larger than 50, 100 will bubble to the right. That means we are swapping 100 and 50. So we are comparing 150 first, then we have swapped 150. Here we can see 50, 100 and 10. Then we will compare 100 with 10. Because 100 is greater than 10, that will bubble to the right. It will move to the right. Then 110 are swapped. So now the array is 50, 10 and 100. Here we can see that 100 is now at the rightmost position. That means 100 is sorted. That is, the maximum element is already present in the rightmost position of the array. In an ascending order, that is what we expect. The maximum element should be to the rightmost of the array. So 100 has bubbled to the right. What we have done is we have compared 100 with 50, we have swapped, and again we have compared 100 with 10 and we have swapped. Then because 100 is already set in its position, it is sorted. Now we will not focus on 100, we will focus only on 50 and 100. So in the second iteration, in the first iteration for I equal to 0, in the second iteration we are focusing on 50 and 100. So 50 when compared with 100, 50 is greater than, 50 when compared with 10, 50 is greater than 10. So we will swap 10 and 50. Then 50 is in its position. Then we can see the 10 is already sorted. The least element is in the leftmost position. Then that shows that the array is sorted. This is how we are doing the BubbleSort. Now we will look at the code and try to understand step by step how we write the code. This is a logic that we use while doing a BubbleSort, but we will look at the code and understand how this logic is implemented. So we are taking an array 100, 50 and 10. The indices are 0, 1 and 2. If we compare with the code, here is the code. The first for loop is starting from I equal to 0 and the inner loop is starting from j equal to 0. The first for loop is starting from I equal to 0, and how far will this loop go? I less than entered array dot length, I less than a dot length, that is I less than 3. That means I will go from I equal to 0 to I equal to 1 and I equal to 2. So I will traverse for 3 values 0, 1 and 2, and for every value of I, when I equal to 0, we will come into the inner loop j equal to 0 and j less than entered array dot length minus I minus 1, that is j less than a dot length minus I minus 1. A dot length is 3 minus I is 0 in this case. 3 minus 0 minus 1, that is 2. So j less than 2 is nothing but j equal to 0 and j equal to 1. So that means for when I equal to 0, j will traverse from j equal to 0 and 1, because the condition is j less than 2. The same code I have written in a short form for I equal to 0, I less than a dot length I plus plus, and similarly the entered array I have called as a. Now this is the same thing that I have discussed. I runs through 0, 1 and 2. When I equal to 0, j runs through 0 and 1. We will look at another iteration when I equal to 1. Let's say I equal to 1. I has incremented from 0 to 1. Then j equal to 0 and j less than a dot length is 3 minus I is 1. 3 minus 1 minus 1. A dot length minus I minus 1 is nothing but 3 minus 1 minus 1. 3 minus 2 is 1. So the condition is j less than 1. J is less than 1. The condition, the values that satisfy the condition j less than 1 are j equal to 0. So when I equal to 1, we will have only j running through 0. It will not go to any other values. When I equal to 2, j will be less than 0. J will be already, for j equal to 0, the condition is j less than 0. So we will not even enter the inner loop. I'm just repeating this statement. When I equal to 2, entered array dot length minus I minus 1 is 3 minus 2 minus 1. 3 minus 3 is 0. That is j less than 0. So the values that satisfy j less than 0 are minus 1 and minus 2 and so on. But we have the default value for inner loop as j equal to 0. So j equal to 0 will not satisfy the condition. So when I equal to 2, we will not even enter the inner loop. This is how the I and j values are changing. So the first condition is I equal to 0. When I equal to 0 and j equal to 0. The condition we are checking is a of j greater than a of j plus 1. That is a of 0 greater than a of 0 plus 1, that is a of 1. A of 0 is 100, a of 1 is 50. 100 is greater than 50. Is 100 greater than 50? Yes, we do a swap. So 100 and 50 are swapped. That is what we have seen in the presentation, in the PPT. 100 is compared with 50 and 100 will swap with 50. So now first element is 50 and second element is 100 and the third element at index 2 is 10. For I equal to 0, as we have noticed, j runs from 0 to 1. So I equal to 0 and j equal to 0 we have just seen. I equal to 0 and j equal to 1 we will see now. J equal to 1, we are comparing a of j, entered array of j greater than entered array of j plus 1. A of j greater than a of j plus 1. A of 1 greater than a of 2. A of 1 is 100, a of 2 is 10. So 100 is greater than 10. Yes, we do a swap. That is what we have seen in the PPT. 100 first compares with 50. We swap 150, then 100 is compared with 10, then we will swap 110. So what we are doing is we are pushing the largest element to the end of the array. So now we can see that 100 is sorted. 100 is sorted means 100 is in the expected position. It is now in its position. Now we will do an iteration where we will compare 50 and 10. Here I is equal to 0. We have come out of the loop I equal to 0. For I equal to 0, j equal to 0 and 1, we have sorted 100 and we have come out of the outer for loop. After that we have I equal to 1. Here it is given I equal to 0, element at index 2, that is a dot length minus 1, a dot length minus I minus 1, that is a dot length is 3, I is 0, 1, that is 2. When I equal to 0, element at index 2 is sorted. That is the reason why we have actually given the value here as entered array dot length minus I minus 1. This statement, how we can consider is, for ith element, when it is sorted, we will compare only the remaining elements 50 and 100. We will not traverse to the last element. So when we write the condition as entered array dot length minus I, the condition is satisfied. But because we are swapping j and j plus 1, we have to give the value as entered array dot length minus I minus 1. After completing this discussion, I will just show you what happens if we write enter array dot length minus I. We will get an exception actually. So that is the reason why we have written the value as entered array dot length minus I minus 1. So max element 100 is at the right position. We have to take j less than a dot length, this is what I have said actually, a dot length minus I minus 1, because for I equal to 0, j less than 2, j runs through 0 and 1, j will not reach the value of 2. In order to make sure that j runs through 0 and 1, we have to give the condition as entered array dot length minus I minus 1. So this we have already discussed. When j equal to 1, we compare a of 1 and 2. As I have said, if we take j less than a dot length minus I, that is j less than 3 minus 0, j will traverse through the values of 0, 1 and 2. For this statement, it is talking about this statement. When j is equal to 1, if we take the condition as entered array dot length minus I only, then j will be less than 3, that is j will take values 0, 1 and 2. When j has taken the value of 2 and we are doing a comparison here, a of j greater than a of j plus 1, a of 2 greater than a of 3. But a of 3 means we do not have an index 3 here, so we will get an exception, index out of bound exception. I will show this at the end of this video, but at this point of time just keep it in mind that is the reason why we have written the statement as entered array dot length minus I minus 1. So where were we? 100 is sorted. So next step that we do is we are comparing a of j with a of j plus 1. We'll compare a of 0 with a of 1. This is when for the second iteration, when I equal to 1. When I equal to 1, j will take values as I have shown here. 1 second. When I equal to 1, j will take value 0. When I equal to 2, we will not enter the loop actually. So when I equal to 1, j equal to 0. Here you can see I is at 1 position and j is at 0 position. Then what we do is a of j greater than a of j plus 1. A of 0 greater than a of 1. we are comparing a of 0 is 50 is greater than 10. 50 is actually greater than 10, so do a swap. So 10, 50 and 100. For I equal to 2, we will we will not enter the inner loop. So 10 is already in the sorted position. So we get the sorted array as 10, 50 and 100. So here we can see that 10, 50 and 100 are already sorted. This is how we write the code for BubbleSort. But as we always do, we will try to run the program in debug mode to understand. Before running the program in debug mode, I will show you this one. In case if I have given the value as entered array dot length minus I, what happens? As you can see, we have got a array index out of bound exception, because here we are comparing j with j plus 1, so that is why we get that error. Now we will try to run the program in debug mode. This is BubbleSort. So this is the same code I have included on the two statements. I am trying to print the value of I and print the value of j, and whenever a swap happens, I am printing it. So as I said, for I equal to 0, j will go from 0 to 1, and when I equal to 1, j will be 0 only, and for I equal to 2, we will not enter the inner loop. So we will do the swaps accordingly. A of j and a of j plus 1 are swapped. A of j is nothing but a of 0 is 100 and a plus 1 is 50. So I will try to run this for another value. See, when I equal to 0, j will run from 0, 1, 2 and 3, because the condition here is j less than entered array dot length. Entered array dot length is 5. 5 minus 0 minus 1 is 4. J less than 4, that means j can take values up to 0, 1, 2 and 3. So this is how the I and j values vary, and we get the output for the BubbleSort. So here we got the output for the BubbleSort. So I strongly advise, please try to run the program in debug mode and try to understand how each value changes at each step. Then you will be able to easily grasp the concept of BubbleSort. Even all insertion sort, BubbleSort and insertion sort, BubbleSort and selection sort are all very similar. If you understand one sort, others are easy to understand. So thank you very much for listening to the video. Thank you once again.